This pancake probe. That is background radiation in your hair right now. If I was to have some kind of a source right up next to it, it would go really higher. Let me get the survey there has a cesium source on it. It's right here, source. So this is used for when we drop doses. Whenever we have doses that we make, they are clear. The liquid is clear. You start doing that all the time, and then it's like you kind of forget. You know, maybe it's kind of so similar to water. So this right here, when I go to drop a dose, will really go like that. So then it reminds you. This is a dose box, one of many different types. We work with Cardinal Health. And the radioactive materials will come here to inside here with inside of a pig. When it gets delivered, this package, see where it says incoming? This is where it gets delivered, right here. When I'm done and they're all empty, it goes over here where it says doses to be returned. Down there, so there's one already there for the driver. For next time he comes, he has to pick that one up. This one is not sitting there. If he was to come today, he cannot take that, even though it looks like it's not, because it's not in the proper to-go area. This is a well counter. This is where you'll put your wipes in. Well counters measure in counts per minute, CPM. You can also convert it to CPS, which are counts per second if you want, but nuclear would mostly do counts per minute. And the wipe goes in here. This is very heavy. There's a hole in there. Do you think the cesium vial or the cesium rod goes in there? The rod, because you can see the hole. Okay, this is a lead shield. You're going to actually draw doses back here. You're going to look through this lead glass. This is lead glass. And we have 6 of them. So I have a list of who is on which station. So today, Alexandra, you're going to be a number 1 for the whole semester. And next semester too. I'm going to have you guys continue on. This is a dose calibrator. We measure doses in here. We do quality control on the dose calibrator using the vial. And we'll actually do quality control called linearity and daily and all this stuff. We'll be doing that. The dose calibrator measures in curies. We use microcuries and millicuries for our doses. In America. Okay. This is L shield number 2, lead shield. Here is another dose calibrator. So every station has a lead shield. Every station has a dose calibrator. These are, well, I'll tell you when I get there. Okay, this is CaliCheck. This is actually quality control for linearity on this piece of equipment here. Dose calibrator. This has to be quarterly done. So nuclear medicine, we have things that have to be done daily, and then we have things that have to be done quarterly. Usually the physicist will do this. I learned how to do it, and I love doing it, so I used to do it myself in my department. L shield number 3, and the dose calibrator. L shield station has also a well counter attached to it. sometimes it doesn't. Okay, this one come here. All around the room. This is where you're going to put your radioactive needles inside here. This is a two-tiered disposal area for radioactive materials. We have the date it was opened, this particular one, the day it closes when we're going to put the lid on it, and the day that we throw it in storage. The one on the bottom here has some stuff rubbed off on it, but all the dates are on here. So there's always one here at the bottom and one here. We always only put radioactive needles in there. We will be working with other needles too. The one, sorry, the 1 year, a couple years ago, there was like all these little buggies here, came out of the thing up there. They were all on the table going, oh my gosh, you know, like that. So. There we go. Good thing I got them before the radioactivity came and made them big. Okay, this is a trash container for, it's lead lined. See, there's another one. It's lead lined. And this is for radioactive trash. This is for blood that has radioactivity in it, which you guys wouldn't know in this place, but you would. Bandages with radioactivity, that kind of stuff. But whenever we take our gloves off after working with radiation, we put them in here. This is dose calibrator area. This is lead shield number 4. Notice it's shorter, more modern than the ones that were donated. 1 and 2 were donated to us. This is number 5. And you'll note that there are different ways of pushing buttons and stuff. There's different brands that do different things and that, which is normal. So, what does a dose calibrator measure in?
Curies.
Microcuries or millicuries. Good. And I mean, once in a while, throw a nanocurie in there for cables. This is a radioactive vent hood. This is for radioactive radionuclides that are volatile. Volatile means that you can breathe it in, the radiation in. And you would work over here with your gloves on with this type of material. One example is iodine 131 liquid. It's volatile. This is number 6, L shield number 6. This one also has a well counter on it too, which is again iffy. And the buttons here, there's certain buttons on here that you'll have to put in yourself. These are rules and regulations. Radiation safety, you're going to go through. This is 10 CFR, part 19, and it contains notices, instructions, inspections, and reporting for workers. So if something happens, you report something. This is 10 CFR. Notice how it's getting thicker. Part 20. This is for radiation protection, permissible doses, concentrations, and waste disposals. You don't need to memorize all this for the registry. What I just told you, the little stuff I just told you is what they'll ask. They'll say 10 CFR 20, what is included, then it says waste disposal, then you would say whatever, yes. This is part 35, this one's thick too, also. Talks about the ALARA principle, as low as achievable, types of requested surveys, instrumentation, training equipment, different things like that, those type of things. So these are the regulations that we use in nuclear medicine to help guide us. And from the NRC, again, State of Ohio, who actually takes care of SSUs because State of Ohio were stricter than that NRC. Over here, these are PM tubes, photo multiplier tubes. These are in the camera. They're different shapes. This is square, round, and hexagonal. The one that's used the most now that we see all the time are the hexagons. So, hexagonal. If you think about it, well, you haven't done camera shots, so I don't want to mess around with it. This is a phantom for thyroids. Whenever we do some kind of a thyroid therapy or something, we have to have a standard, a baseline, and then we give the patient the capsule or whatever. But we have to measure the capsule first and all that. That's just called a thyroid phantom. We have radioactive spill kits all set up in our departments. Inside this one, you'll have maybe some booties, gloves, stickers with radioactivity, tape, gauze, blue pads, and red disposable biohazards, or you may have actually nuclear yellow and magenta bags to use. And there's certain rules that you need to follow for that. These are survey meters. This is a probe because of its long thing here. And then this is a pancake probe. This is pancake, this is just a regular probe. And they do look like they're from the 30s. As I said, we gotta think of something, you know, to make it more up to date. These are measured in MR per hour. MR per hour. And on each one there is a slightly radioactive cesium button, very small amount. And that's what we use to quality control. This is one of the things that we quality control every day. So you're gonna practice doing that. And then I'll show you how to measure certain items in that. This right here is a cutie pie. Cutie pies can read and tell if there are alphas, betas, gamma rays. These guys here that we use do not. This only tells if there's radiation there. Doesn't say what kind of radiation. This is a purse, a lead-lined purse that we will use to open up. It opens up. It's heavy. And actually we have a radioactive source inside, pretend, of a iodine pill. You could use this, you can put your dose in here, and you can carry this into any room or even upstairs to inject for bone scan. This also is something to put a radioactive dose in, and you can carry it too. So it's all this is lead lined, very heavy. I had a parent in here. These right here are lead pigs. Lead pigs come in various sizes and shapes. This one here is for a pet dose of 511 keV. This right here could be for a tech dose of whatever, sulfur colloid, MGP, or whatever. This right here is cardiolite. This is a heart dose. This is lead. They're all lead. These are lead syringe shields that we use in nuclear medicine every day. You want to protect yourself from the radioactive syringe and the liquid inside. 3 cc syringes are used to inject patients. 5 cc's are used to make up kits because it's bigger and larger amount. These are lead vials, and you would actually unscrew this here, and you would put fake it inside here, and then you would screw that on there so that when this is radioactive, you don't want to be handling it other than, with lead on it and that. These are safety glasses. Every department needs to have them. close to where you inject patients. And this right here is a non-radioactive area to put your needles in. This is called just a regular sharps container. If this was put over there with that lead-lined one, then that would be radioactive sharps container. These are forceps, has the grounded area on it. And these are hemostats with a little pointy area. And then we have various kits. Inside the kit will be a little bit of white powder, depending on what dose or what you're going to do, procedure you're going to do. And you need to mix it with technetium, and then it's radioactive, and then it will go to the area or the organ that you wish it to go to. It's more complicated than that, just give me your business. This is a thyroid probe used for thyroids. This is our classroom. This is baby yoga. This is our pilot lab. And I do want to show you one other thing. Pika, can you bring me a pair of mediums for me?
Mm-hmm.